Today I'm going to discuss some of the questions that came up in the term 3 assessment 1 and 2. Now come to the first one, that is question number 6 from the application part of term 3 assessment 1. And the question was, if an object is kept at a distance 30 centimeter from the pole of a spherical mirror, here as shown in the diagram. The object is kept at 30 centimeter from the pole. An inverted image of the size equal to the size of object is formed. Then answer the following. Name the mirror. Okay. You can easily name the mirror because the image is inverted. Okay. Inverted image is formed. And we know that only concave mirror can produce inverted or real image. Okay, so the mirror is concave. Okay, so now draw the concave mirror here. Okay, so this is concave mirror, and the image is formed whose size is equal to the size of the object. And this situation is possible only when the object is at center of curvature of the mirror. Okay, so this will be the center of curvature, and we get the image of this object at the center of curvature. Okay, so this is the image of the object. When the object is at center of curvature of the concave mirror, then we get image of equal size and at the same place, means at the center of curvature. Okay, so come to the second part, that is, what is the distance of image from the pole. So you can easily find the distance of image from the pole, which is equal to the distance of object from the pole, that is 30 centimeter. So the distance of image from the pole is 30 centimeter. Okay, now what is the focal length of the mirror? Here this distance is the radius of curvature, means 30 centimeter is the radius of curvature, that is the distance of center of curvature from the pole. Okay, so radius of curvature is equals to Cp, which is equal to 30 centimeter. Okay, now the focal length is given by half of the radius of curvature, that is 30 divided by 2, and it is 15 centimeter. So the focal length of the mirror is 15 centimeter. Okay, so this is the solution. Now come to the next question, that is question number 7 from the application part, and the question is, in the following diagram mark the angle of incidence and angle of reflection. Okay, in the diagram a ray is reflected from the reflecting surface of a convex mirror. So this green ray is the incident ray, and incident at point O, and the ray is reflected in such a way that the angle between the incident ray and the reflected ray is 60 degree. Okay. In order to mark the angle of incident and angle of reflection, first we have to draw normal, because all the angles are measured from a reference line known as normal. Okay. In order to draw normal at point O, I have already told you, just join this point of incidence with the center of curvature of the mirror and produce that line. That line will be the normal at the point of incidence. Okay. So to draw the normal at point O, connect the point with the center of curvature. Okay. Okay. And produce that line. This line would be normal. Okay. At the point of incidence. And we know that this normal divides the angle equally, because we know that angle of incidence is equal to the angle of reflection, I and R. Okay. Angle I should be equal to angle R, because this is the law of reflection, and the sum of these two is equal to 60 degree. It means angle I plus angle R is equals to 60. Okay. I is equal to R, so we can put R as I is equals to 60, means angle I is equals to 60 divided by 2, which is equals to 30. Okay, so angle I is 30, which is also equal to angle R. Okay, so angle of incidence is equal to angle of reflection, which is equal to 30 degree. Okay, because this normal line divides the angle equally. Okay. Now come to the next question, that is question number 2 from the comprehension and analysis part of term 3 assessment 2. The question is, a bucket kept under a running tap is getting filled with water. A person sitting at a distance is able to get an idea when the bucket is about to be filled. First part, what change take place in the sound to give this idea? And the second part is, what causes the change in the sound? As the water level increases in the bucket, the length of the air column inside the bucket decreases. Here in the diagram, when the water level is here, the length of the air column is this much. Okay, and as the water level increases, the length of the air column decreases. Okay, since we know that the frequency of a sound is inversely proportional to the length of air column. Okay, as the length of the air column decreases, frequency of the sound increases. Okay, and here, as the water level increases, the length of the air column in the bucket decreases, and that will increase the frequency of the sound produced. Okay, and this increase in frequency or change in frequency gives the idea, okay, that the bucket is about to be filled. So the answer of the first part is, what change take place in the sound to give this idea? Frequency. Frequency or pitch. Okay. Frequency of the sound changes, and that will give you the idea of filling the bucket. Now, the answer of the second part, that is, what causes the change in the sound? So, the change in the length of the air column. Okay. Change in length of air column changes the frequency. Okay. So this is the answer of the second part, that is, the change in the length of air column changes the frequency of the sound. Okay. Now next question is question number 5 from the comprehension and analysis skill, that is, two children are using a string telephone to communicate each other in two different situations. In the first situation, the string hang loose. Okay, this is the situation 1. But in the other situation, the string is pulled tight. This is the second situation. Now first part is, write the observations of the listener in both the situations. And second part, what conclusion can you draw on the basis of the observations? So in the first case, when the string is loose, it means there is no tension. Okay, in the string there is no tension in a string. Okay, and in this case the listener doesn't hear any voice of the speaker. Okay, listener doesn't hear anything. Okay, so this is the observation of the listener in first case. The listener doesn't hear anything. Now come to the second situation. When the string is pulled tight, it means the string is under tension. The string is under tension. When tension increases, then the listener hear the voice of the speaker. Okay, listener hear the clear voice of a speaker. Okay, due to the increase tension in the string. Okay, so the conclusion is, on increasing the tension, or the tension in the string supports the propagation of sound through the string. Okay, the conclusion is, what is the conclusion? The conclusion is, tension in the string supports the propagation of sound through the string. Okay, now come to the next question, that is from the application part. Question number 2. We hear two distinct sounds when a person strikes a hammer on the railway lines from a distance. Why is it so? Okay, consider this is the railway line track, and this track is made of steel. Okay, when you strike a hammer at this point here, at point A, when you strike a hammer at point A, then there are two sound waves produced. Okay, one in the air, okay, which is just above the track, and second wave produced in the steel. Okay, so there are two sound 1 and sound 2. Sound 1 is produced in the air and sound 2 is produced in the steel. Okay, when you strike a hammer at this end. Okay, now these two sounds propagate in two different medium. Since we know that the speed of sound is maximum in solids and minimum in gas. Okay, so this sound 2 will propagate faster than sound 1, because sound 2 is propagating in solid medium and sound 1 is propagating in gaseous medium. Okay, and if you are here at point B, okay, then you will get the sound 2 first and then sound 1 later, after some time. Okay, that's why you hear two sounds when you strike hammer on the railway line. Okay, so this is the answer. Now come to the next question, that is third question of application part, that is the whistle produces sound of a unique frequency while the flute produces sound of different frequencies. How is it possible? Okay, here we have the diagrams of whistle and flute. Okay, here you can see that whistle has a unique length of air column. Okay, that cannot be adjusted. Okay, so whistle has a fixed length of air column. Okay, fixed length of air column. Hence the whistle produce sound of unique frequency or fixed frequency, because the length of the air column is fixed. But in the case of flute, the length of the air column can be changed by closing the openings provided in the flute. Okay, so the length of the air column can be changed. The length of air column can be changed in flute by closing the holes or openings given in the flute. That's why we can produce sound of different frequencies by changing the length of air column, okay,